Hello, everybody. Today we're going to talk about cognitive foundations, which is chapter 3 in our textbook. Here is a quote from an adolescent. "I don't think adults understand how much kids think today. We just don't take something at face value. We want to understand why things are the way they are and the reasons behind things. We want it to be a better world, and we are thinking all the time about how to make it that way. When we get to be adults, we will make the world better." I think that's a nice quote as we get into talking about cognition and thinking in adolescence and early adulthood. So there are some different theories about cognition. You might have heard of Piaget's theory of cognitive development before. Piaget earned his doctorate in biology actually in 1918. And at that time, scientists really thought that infants didn't do much. They ate, cried, slept. No one was really concerned about infants' cognition. But Piaget used a scientific approach to study his own children. And he came up with different stages that children developed their cognitive abilities in different stages that we'll talk about. And the stages are right here: sensory motor, the first 2 years, pre-operational comes after that, then concrete operations and formal operations. So Piaget had this fundamental assumption in his theory that children are mentally active from birth. They're always seeking new experiences, they're trying to learn, they're experiencing the world. And that it's children's mental and physical activity that contribute to their cognitive development. That if infants are moving around, exploring the world, that's helping them learn. Which leads to the idea of a constructivist approach to cognitive development, that children really construct knowledge for themselves in response to their experiences. And so in this constructive process, they generate hypotheses, and this doesn't have to be like a science class, right? Just what happens if I pick up this block? Is it going to, and I drop it, is it going to fall down? Is it going to fly up, right? What is my hypothesis? Then they perform experiments like, let me see what happens. Now I will drop the block, and then draw conclusions from their observations. And so Piaget coined this term, little scientists, that's how children start to learn about their world. Central properties of Piaget's stage theory is that there are qualitative changes between each stage, meaning each stage is very different cognitively from the one before. And you've got the sensory motor stage, pre-operational, concrete operational, and formal operational. When we talk about a qualitative change, we mean that each stage is very different, kind of like a caterpillar then turns into a butterfly. Those two stages are very different. There's broad applicability of Piaget's ideas, so they can extend to many aspects of cognition, which we'll talk about. There are very brief transitions between the stages. So a young child is in the sensory motor stage, and then there's a very brief transition before moving to this qualitatively different pre-operational stage. And the idea of an invariant sequence, meaning that children go through these stages in this order. You can't skip a stage, you can't go from sensory motor to concrete operational and then pre-operational. It must go in this order. So some of the central developmental issues in Piaget's theory is that nature and nurture interact to produce cognitive development. And so Piaget believes that the brain is developing, and I'm actually going to go back here for a second, and that the brain has to be at a certain stage of development for a child to move from one stage to another. Okay, and so it's quite dependent on nature as well as nurture in terms of the child exploring and experimenting in the world around them. In terms of a continuous process between these stages, Piaget uses these terms, assimilation and accommodation. So assimilation is the idea that a child starts to learn, let's say, a category, and starts to put everything they see in this category. So a child has a dog, let's say as a pet, and realizes that the dog has 4 legs and is furry. And then anytime a child sees a furry 4-legged animal, they'll call it a dog. So they'll call their pet a dog. Maybe they go to their grandparents' house and the grandparents have a dog. Maybe it's a different type of dog, but they'll say dog, 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 everything that has 4 legs and is furry. But if a child then sees, let's say, a mouse, which also has 4 legs and is furry, and says dog, and then a parent or caregiver is going to say, oh, that's not a dog, that's a mouse. The child then needs to accommodate, meaning they need to improve or change their understanding of what that category is. Okay, so something that's very small and has 4 legs and is furry and has a long tail, that is going to be, we'll call that mouse, and other 4-legged furry animals are called dog. And so through this process of assimilation and accommodation, eventually the child gets to equilibrium where these processes have led to a stable understanding of any particular concept. And in terms of discontinuity, meaning, not a continuous process, it's really his idea of the stages of cognitive development, that each of these stages are their own qualitatively different stage. So basic principles of Piaget's theory, we call this a cognitive developmental approach. Developed, like I said, by Piaget. It's an interaction between biology and environment that leads to intellectual growth. And each stage is characterized by a particular type of thought. And maturation, so again, this brain maturation, this brain development is the driving force behind developing from one stage to the next. And so from ages 0 to 2, that's the sensory motor stage. And this is where children learn through their senses and their motor activities. So how do they learn? By seeing things, by hearing things, by touching things, and by moving around and exploring the world. Pre-operational, this is where children are starting to be capable of symbolic representation, like they can use a number, 1, 2, 3, or 4 to represent an amount of an object, or a letter to represent a sound, but they have limited use of mental operations. Between ages 7 and 11, we're at concrete operations. So here children are capable of mental operations like doing math, adding, subtracting, multiplying, dividing, but in concrete, immediate ways. They have difficulty thinking hypothetically. And then from 11 on, it's kind of where we're focusing on in this class, formal operations. This is where children start to become capable of thinking logically, thinking in an abstract way, coming up with hypotheses and testing them in a systematic way. Thinking is more complex. You can use representations of different ideas, and we can even think about our own thinking, which is called metacognition. I'm going to go through this in a minute. So adolescent thinking becomes more abstract and more complex. So the idea of abstract thinking, understanding time, thinking about friendship, faith, those concepts that are much bigger than something more immediate, like let's count how many objects are here and then, I don't know, add another amount of objects and put them together. Metacognition, self-awareness of your thinking process. So what you think of others, trying to think about what other people think about you. That's all metacognition. And that adolescents start to see things in greater complexity and perceive multiple aspects of a situation, right? That's key, that there's not only one way to think about something, that there are multiple perspectives, and understanding that someone might have a perspective different than you. And this stage, we're starting to understand metaphors, understanding the literal concrete meaning as well as the less obvious, more subtle meanings. Sarcasm, that you say something, but it may not, the words you say may not actually represent the meaning based on somebody's tone and the context in which they say it. So some examples, thinking about the way your life might be affected by different career choices. This is very complex, and adolescents have to do this. Do I want to go to college? What would that mean for me in the future? Do I want to be a teacher? Do I want to be a restaurant owner? Do I want to be an engineer? How would that affect my life? All of those are very complex thoughts that adolescents can start to do at this time in their life. They can move between specifics and abstract, generate alternative possibilities, work on deductive reasoning and if-then thinking. If I do this, then this will happen. Understanding higher order abstract logic, we already talked about puns, proverbs, metaphors, looking at things from more than one aspect at a time, and sarcasm. And as I said, metacognition is an important thought or cognitive ability that starts to happen in this time, thinking about thinking. So you can monitor your own cognitive ability during thinking. So we have increased introspection, thinking about your own emotions, increased self-consciousness, thinking about what others are thinking of us, and increased intellectualization, thinking about our own thoughts. Some limitations of Piaget's theory is that there are individual differences in these formal operations that we're talking about. Piaget believed most people proceeded through the same stages at about the same ages because they experienced the same maturational process. And research has proven this wrong, that some children enter these different stages at quite different ages. And that very strict from 0 to 2, you're in this stage, and from 2 to 7, you're at this stage, is not necessarily accurate. Also, Piaget's theory really did not look very much at culture. And so in terms of culture and formal operations, we see that people from all cultures don't all develop to this stage of formal operational thought. And so we have to apply Piaget's ideas to the materials and tasks that are specific to that culture. So when we talk about formal operations, we're very often talking about algebra and being able to use variables and things like that. Well, there are many cultures where algebra is not maybe their, what's going on at 17, 18 years old, but there are other more abstract tasks that they're doing just in a very different way than perhaps in our culture. And so we need to sort of think about this theory and study this theory in different cultures as well. Cognitive development in emerging adulthood. Okay, so emerging adulthood, right? We're thinking about early 20s. We call this post-formal thinking. This is a type of thinking beyond formal operations, involving greater awareness of the complexity of real life situations, such as the use of pragmatism and reflective thought and judgment. And you can look through this in your book as well. This is a lot of words for this slide, but pragmatism, right? type of thinking that involves adapting logical thinking to the practical constraints of a real life situation. Well, like, this is what I'd like to do, but given the situation I'm in, what can I really do, right? Reflective judgment, multiple thinking, all of these very complex types of thought, we would call that post-formal thinking. Another theory, cognitive theory that we talk a lot about, so moving away from Piaget, is what's called the information processing theory. And this is the idea that our cognitive systems and mental activities basically focus on different structures in the brain, and that the brain is very much thought as a computer. It's kind of the model that we use in information processing. So the idea that different parts of the computer or different parts of the brain are responsible for different tasks. And the goal here is to break down a cognitive task into its different component parts and see if we can understand how somebody's able to solve a complex problem or remember something from many years ago, etc. So in an information processing theory, the child is basically a limited capacity processing system. It's not, all the parts of the brain are not online yet. And cognitive development arises as the child, the processing limitations basically are decreased. And so over time, the child can start to process more information at a time, increase the processing speed of information, and acquire new strategies and knowledge, which then helps the child solve more complex problems. So the child goes through active problem solving, the process of attaining a goal by using a strategy to overcome an obstacle, right? I've got to solve this math problem. How am I going to be able to do that? So one area that's been studied quite a bit in this information processing approach is memory. In fact, I wrote my dissertation on memory kind of using this approach. And the idea that there are three different main functions that need to happen for memory to work in the way that we understand it to work. So the first process would be encoding, which is the process of representing in memory information that draws your attention or is considered important. So as you're looking around the room, if you're in a classroom, if you're outside, wherever you are, anything that you look at or that you hear, that you pay somewhat attention to, is encoded. It's brought into your brain, right? While most stimuli is screened out, you couldn't possibly remember every single thing you're looking at. The things we deem important enter through our senses. So we also call this sensory input or sensory encoding. So through our eyes, our ears, something we taste, something we touch, and that is brought into our brain. It's encoded. At that point, we enter what's called short-term or working memory, and this is information that we're paying attention to or that we're working with, lives in our working memory for a short amount of time. In fact, you can hold about 7 or 8 things in your working memory at a time for about 20 to 30 seconds. You could think about this as, this used to happen many years ago. Now with cell phones, not so much, but people would tell you their phone number, like, hey, give me a call, here's my phone number. And they'd tell you those 7 digits, and you had to kind of remember them by working with them, by repeating them in your mind, by doing something to remember that information. And if you stopped thinking about it, after about 20 or 30 seconds, you would not remember those numbers anymore. And then long-term memory, so this is information that you accumulate over your lifetime, information that you work on in short-term memory, that you practice, that you rehearse, that you repeat, that's deemed to be very important, can make it into long-term memory. And in long-term memory, we think you can hold basically unlimited information for an infinite amount of time. So that's not to say that you'll always remember it easily. Sometimes it's in your memory, but you're not able to oh, what was the name of my teacher in 4th grade or something. It may be hard to retrieve. That's another process, retrieval. But we believe that that information is in your long-term memory. In terms of some information processing theories, attention, so selective attention, being able to decide what you're going to pay attention to, that gets better as you get older, whereas young children are kind of paying attention to everything or not able to selectively attend. They're often overwhelmed by information around them. And then being able to divide your attention to multiple things going on. Also, it gets better as we get older, although divided attention may result in less effective learning, right? If you're splitting your attention to multiple things. Executive functioning. This is a type of thinking that we believe is housed in our frontal lobes, particularly in the prefrontal cortex. It's one of the most complex and least understood areas of the brain, the frontal lobes. It's the largest lobe in the human brain. About 1/3 of our cortex is the frontal lobes. It's the latest of the lobes to develop and myelinate. So if you think about brain development and brain myelination, starting at the very back, brainstem, and then working its way forward. In fact, we believe that the frontal lobes don't finish developing until people are in their mid-20s. So that's a really late developmental process. The executive function and the frontal lobes seem to mediate behavior that we call distinctly human, like our ability to plan, to be flexible in our thinking, to have abstract thought, to be appropriate, to know when it's appropriate to act in one way versus when it's appropriate to act in another way based on, society's rules, etc. All of that seems to be housed in our frontal lobes. How are executive functions applied through the lifespan? They're very important, and there's lots of research being done on executive functioning. So they inhibit tempting actions that can cause difficulties. Think about, studying. Nobody wants to study necessarily, but you should study if you want to do well in class. But there's a lot of things that are more tempting, like playing video games or watching a movie or hanging out with friends. We believe it's your frontal lobe that inhibits those tempting actions, saying, okay, I'm not going to see my friends tonight. Instead, I'm going to study. Executive functions enhance working memory, helps us with strategies like, if I repeat something over and over, that's one way that I can remember this information. Or I could come up with a song or a rhyme or something to help me remember. And then being cognitively flexible, like taking another person's perspective in an argument, even if it's different than yours. Those are all executive functioning skills. You can see here, focusing, planning, organizing. I could use a little help in that. Time management, self-control. These are really important executive functioning skills that we believed are housed in the frontal lobe, and that doesn't fully develop until someone's in their mid-20s. And so when teenagers have trouble planning or organizing or focusing, we can't always blame them because they don't have fully functioning frontal lobes. And so I've done a lot of talks for parents and teachers and of adolescents, and I always say, you as a parent or teacher have to be your child's frontal lobes. Their frontal lobes aren't working yet, so we sometimes need to put in the organizational strategy, help them with focus, like, no, you won't have a TV in your room because they're going to want to watch the TV while they're studying. Things like that to help their child while the frontal lobes are still functioning. Let's see, basic processes in terms of the development of memory. We can start associating events with one another. As memory develops, we recognize certain objects as familiar. We're able to recall facts and procedures. We can start generalizing from one instance to another. Oh, this happened last time I did this. How's it going to be in this situation? We start to encode specific features of objects and events and improve processing speed, which helps with memory. As the brain myelinates and the layer of myelin forms on your neurons, that increases connectivity and speed of connectivity, which helps with memory. In terms of some strategies that help to explain the development of memory, selective attention. So the process of intentionally focusing on information that is most relevant to your current goal. So if you can selectively attend to what you're trying to remember, that's going to help, as opposed to being distracted by lots of things around you. Rehearsal, we know rehearsal is very important for memory, repeating information multiple times in order to remember. Like I said, I did my dissertation on memory, and truly there is no shortcut to memory. Repetition is key. And then content knowledge. As your knowledge increases just about the world in general, that improves your recall, and integration of new information becomes easier to remember. Prior content knowledge improves encoding, provides useful associations, and guides memory in useful directions. So some limitations of the information processing approach that we've been talking about, thinking about the different processes and the different parts of the brain that have to be used in order to complete a task, is the idea of reductionism, that if we break up a phenomenon into separate parts, at some point the extent and the meaning and the coherence of what we've done as a whole becomes lost, right? If we think about memory and break it up into all these small component parts, we almost sort of miss the phenomenon of, wow, that's pretty impressive that I remember, I don't know, what I wore to my 8th grade graduation. Fails to consider how human cognition works as a whole, rather than bringing it down to this set of isolated parts. And if we use that computer idea or computer model, computers don't have all of the things that people have, like self-reflection, self-awareness, emotions, and those things certainly impact our cognition. Critical thinking and decision-making. Critical thinking that involves not merely memorizing information, but analyzing it, making judgments about what it means, relating it to other information, considering ways it might be valid or invalid. So our ability to analyze and make judgments about new information is enhanced as individuals get older. We're able to simultaneously consider different kinds of knowledge, which makes critical thinking more possible. And we have more metacognitive strategies available, right? Like, what would someone else think about this? How am I thinking about this, etc. Good question. Can adolescents make competent decisions? Competence in decisions varies with age, basically. As adolescents get older, they're better at anticipating consequences than pre-adolescents. And those skills continue to improve into adulthood. We see that adolescents take more risks than adults. They often don't think about the consequences quite as much. And adolescents are more strongly influenced by emotions and psychosocial factors like their peers or the situation they find themselves in than their critical thinking skills. In terms of social cognition, how people feel about others, social relationships, and social institutions, one of the keys to social cognition is perspective taking, or the ability to understand the thoughts and feelings of others. One aspect is theory of mind. Theory of mind is the ability to attribute mental states to others, to yourself and to others, including other people's beliefs, thoughts, and feelings. And we test theory of mind, particularly in young children, with what's called the false belief problem. Here's an example here, where here's a young child with an adult, and another adult is hiding a toy in a drawer here, and the child and this other adult are watching. This adult walks away, and the child sees that the adult walks away, and then the other adult moves the toy from the drawer to under the bed. And then we say the other adult walks back in. Where will she look for the toy? Now, if a child has not developed a theory of mind yet, the child will say, well, I saw that the toy was moved to under the bed, so she will think that the toy is under the bed, right? Not being able to differentiate between the child's perspective and this other person's perspective. Whereas if the child has developed theory of mind, the child will say, well, this other adult will believe it's in the drawer because that's what she last saw, that the toy was in the drawer, even though I know that it's been moved. So this is a higher level kind of ability to take another perspective. In adolescence, we see some particular aspects of social cognition that we call adolescent egocentrism. It doesn't mean that they're egotistical or anything like that, just that a lot of times their thought process revolves around themselves. So for example, we see what's called an imaginary audience or belief in an imaginary audience in adolescence. This is the belief that everyone is watching them and that adolescents' behavior is the focus of everyone else. A adolescent has a zit on their face, and they feel when they walk into school, everybody's looking at them. Everybody's looking at their skin, which is not true, right? Probably nobody cares. Nobody's looking. But there's this belief that they're the center of everybody's attention. And then another aspect of social cognition in adolescence is the personal fable. The idea that adolescents often believe that their experience is extremely unique, that no one has experienced what they're experiencing before, and nothing bad can happen to them because they are so special. Couple different examples, like experience are unique, when maybe adolescent experiences a breakup and they feel like nobody can understand me, nobody understands this experience, nobody understands how I'm feeling, even though everybody has at some point, and adults and parents can relate to feelings of being broken up with. Adolescents often feel like I'm the only one who's ever felt this way and this much pain. And this nothing bad can happen to them because their special leads to often very risky behavior, right? They couldn't possibly get in a car accident and be really hurt. So they might, drive risky or do risky things because, again, they're special. Nothing bad could happen to them. Your chapter also talks about general cognitive functioning and intelligence, which we'll briefly talk about. So what is intelligence? We could talk about this all semester, but we won't. So the ability to learn, to solve problems, to recognize problems, all of that would fall into the category of intelligence. The dictionary definition knowledge possessed by a person, their ability to think and learn, their capacity to adapt to new situations, and we could think of many, many other definitions of intelligence. How do we measure intelligence? We use what's called the psychometric approach. We attempt to understand human cognition by evaluating cognitive abilities using intelligence tests. And there are different intelligence tests. The WISC, or the Wechsler Intelligence Scale for Children, that's used to test as an IQ test for children ages 6 through 16. And then the Wechsler Adult Intelligence Scale, or the WACE, and these are different versions. So we're now at the WISC 4 or 5, and the WACE 5. It's just like your textbook gets new revisions, IQ tests get new revisions. So the WACE is for ages 16 and up. There are 6 verbal subtests and 5 performance, or what we call nonverbal subtests. And it gives you an overall IQ score based on established norms for different age groups. And so here are some examples of the subtests. So some verbal subtests. So there's a section about, we call it information. These are general knowledge questions like who wrote Huckleberry Finn, things like that. There's a section on vocabulary where you give definitions. So someone would be asking you, what does formulate mean? And lots of other questions in the vocabulary section. There's a similarity section where you ask someone to describe the relationship between two things, like in what ways are an apple and an orange alike? Or in what way are a book and a movie alike? And so the person answers those questions. There's verbal arithmetic problems. There's what we call comprehension problems. These are practical knowledge, like why is it important to use zip codes when you mail letters? And then digit span, this is a short-term memory test where sequences of numbers are given and the person has to repeat them back, right? So I say 3, 4, 7, and then the person taking the test has to say 3, 4, 7, and then we use more and more digits to measure their short-term memory. All right. And then some visuospatial or the performance problems. There's block design where you have these different blocks that are half white, in this case half purple. Some sides are white, some sides are purple, and some sides are half white and half purple. And they have to put the blocks together to make a particular design that's shown to them. Fluid reasoning, pick an object from each pair that goes together. Right, so the tools or something like that. Working memory, you could take a look at that. Processing speed. Under each square, put a plus. Under each circle, put a minus. Under each triangle, put an X. And they have to do that as quickly as you can. Things like that. So another terms that are used in terms of intelligence are fluid and crystallized intelligence. Fluid intelligence, this is kind of like problem-solving intelligence. And these are very often tested more so by the performance subtest. How do you kind of do something on the fly that you haven't learned before, that you're kind of figuring out how to do as you go along? Versus crystallized intelligence, this is your knowledge base. And this is really measured very much by the verbal subtests like vocabulary skills and information and comprehension. Lastly, we're going to talk about sociocultural theories of cognitive development. There are so many theories of cognitive development. We're just covering a few. In terms of cognitive development, Vygotsky is the name that very often comes to mind. And this is the idea that interpersonal processes, society, other people are really critical to cognitive development. That cognitive development is a collaborative process between the child and more knowledgeable mentors. And those more knowledgeable mentors could be parents, could be teachers, could be peers who understand the topic, could be siblings, and that it's really people that cause cognitive growth. It's this interaction between the child or adolescent and more knowledgeable people teaching them. And so the theory here is that cognitive development is embedded in a social context. The children are curious, they observe, they ask questions. If you've ever been with a little child, they're always asking questions. What is this? What is that? Why do we do this? And so there are mentors who, like I said, parents, teachers, peers, that present challenges to the child, offer assistance, help the child or adolescent do the task, add crucial information that they're missing, and encourage motivation. And through that interaction between the child or adolescent and a more knowledgeable mentor, the individual learns. So that's a different view on cognition. All right, thank you very much, everybody.